Recently I've seen some videos about physics simulations and I thought they looked pretty cool, so I've decided to make one myself. Let's get it. Alright, this should hopefully give me a black screen when I run it. Nice. With a blank window up, I got to rendering circles on the screen. This should hopefully give me a red circle on the screen when I run it. And I got an error. Let me run this again. Still nothing. Hopefully, this gives me a red circle. That is not red. Alright, now it should be red. Nice. Now it was time to make our red circle move. In order to do this, I used Euler's method, which according to Wikipedia is the most basic, explicit method for numerical integration. It is given by these formulas. Now this is going to form the basis for our physics integrator. Whatever that is, I just heard that word, but I'm pretty sure all it does is just like control where the circles go next, so yeah. Try that. Oh, it's getting bigger. I think this bit is what's called a numerical integrator. Alright, time to add Verlet Integration, or whatever it's called. This is the Verlet Integration formula. It can be derived from Euler's method, but offers significantly improved stability without introducing much additional computational overhead. The formula is in terms of previous position, current position, and acceleration, so I have to change the object struct to account for this. And nothing's happening. Why is nothing happening? Okay, nice. This is Verlet Integration. Now to add more objects. They don't do much, but it's cool. Now to make them collide with each other. Making the circles collide with each other is split into two parts: detecting the collision and resolving the collision, which is basically just moving the objects apart. To detect the collision, we first find the distance between the centers of the two circles using Pythagoras. If the distance is less than the sum of the two radii, then the circles are colliding. But if the distance is greater than the sum of the two radii, then they are not colliding. To resolve the collision, we find the direction along which the collision happened and move the object enough to get them out of the way. Each object is moved by half of the overlap, and this overlap is calculated by subtracting the sum of the radii from the distance between the two centers, which was calculated in the previous step. Ooh, that doesn't look right. Alright, I was rewatching Pez's video and I think I realized a mistake I made. Does this work now? Oh, that looks good. That looks really good. Oh my days. Nice. I quickly made a circle constraint like in Pez's video and tested the code with different sized objects. Oh, looks fine. Bit jittery, but it looks good. Does lag a bit when I add more balls, so some optimizations are probably needed. Now it turns out I made a few errors. One caused the jittering and the other caused the lag, but I'll get to them soon. I also want to take into account the mass of object. I don't know exactly how to do this. My collision resolver worked by moving objects based on the ratio of their mass. So an object with a mass of 10 would move twice as much as an object with a mass of 20. So hopefully I'll see the bigger balls moving less. So that's a medium-sized ball. They're about the same mass, but yeah, that one moves it a lot more. Let me try rerun it and see if I get a better example. Yep. Yeah, and that, see how that barely moves it. I think it's working correctly. And the next thing I want to add is line segments. So let's do that, I guess. The physics for line segments is very similar to the example with two circles. We first find the distance from the center to the closest point on the line segment. If this distance is smaller than the circle's radius, then it's colliding with the line segment. Otherwise, there is no collision. If there is a collision, we displace the circle by the overlap so it no longer touches the line segment. Yeah, nice. I think it's working. That looks normal. I've made this little arrangement of ramps. Pretty cool. But yeah, this is really cool. But placing these manually is quite annoying. Like in my code, I literally have to define each line segment. So I'm probably going to quickly try and make a tool that allows you to place lines wherever I want. So yeah. Alright, hopefully I should be able to place down my own line segments now. Just going to place a little ramp here. Oh my days, it works perfectly. Oh, that's so cool. Try it like that. Hey. It kind of works. It's pretty cool. I quickly added the ability to see lines as you're placing them, and the ability to delete the previous lines you've placed. I've just added this GUI window, so now I can see the frame average, which is pretty handy, and the object count. Oh, that's not good. Only after 41 objects it starts to get laggy. That is not great. I also need to fix whatever is going on here. They keep bouncing off each other like this. Yeah, so these were the two errors I was referring to earlier, and I'm just going to let the clips play. Oh my days, how I not found this out earlier. Oh my days. Okay, here in this function, I'm looping through all the objects. And for each object, I'm checking collisions for each object again. Oh my days. Oh my days. I don't know how I made this mistake. No wonder it was lagging. Okay, that's good. I don't know how I made that mistake. No way. I'm doing the exact same thing here with the line segments function. Oh my days. Why is it jittering? I need to fix this. The thing that was causing the jittering was my collision resolver. I wasn't actually moving the objects out of the way of each other. This led to some weird behavior, but I got it fixed for the circle collisions and the line segment collisions. I was a bit reluctant to show the code for the collisions, but now that it's fixed, here it is. Alright, now to add chains. The physics for the chains is quite simple. Every physics frame, I check the distance between the two chained circles. If it is not equal to the desired length, I find the direction between the two objects and move each object enough along this direction until they are at the desired distance. And yeah, the objects are linked. So now they stay at a constant distance from one another. Here is the code for the chains. But now I want to lock one of them so I can get a chain of them. Alright. Hopefully The top will be locked now. Doesn't look right. Oh, I think that seemed to work. Bit janky, but hey, it's fine. Oh, nice. That worked. Alright, after a lot of reworking, finally got chains being displayed, which is quite nice. Now I'm going to try and make like a triangle type object. Alright, hopefully when I run it, there should be a triangle in this corner of the screen. Oh, okay. Yeah, it's working. That's kind of nice. So I wonder if I can get like a large group of them. I feel like at that point I may as well make a function for it though. Now that I've made it a function, I should be able to simply update the object size and have more objects. I'm gonna try it with 4. The issue is now they're starting to fall on top of each other. You can see here it's not actually a square, it's kind of like a parallelogram. So the way I would fix that is probably by adding lines in between there. Oh, this can be quite difficult. Oh dear, I have no clue what's going on. Well, that seems to work. Kind of. For some reason, when I made a chained object with more than like 5 circles, it would glitch out. I'm guessing the reason why the objects freak out is because I'm not averaging the movements for each chain on a single circle. Anyway, for some reason, if I create 2 chains for each connection, it doesn't glitch out. I don't know why this specifically fixes it, but I'll just deal with it. Alright, the next thing I want to add are some better controls, because like right now, if I wanted to, for example, move this object onto there, I have no good way of doing so. Or if I have a line like so, I want to delete this one specifically, can't do that, I have to delete all the other ones. So I just want to add some more controls to make, you know, playing around with the simulation more fun and to make testing easier. After a lot of work, I made this control panel. This allows me to place many objects very quickly, change the mass and size of objects, make and delete any lines I want, create chains in chained objects, change the direction of gravity, and move objects. Any resources I've used will be linked in the description. If you made it this far, I want to thank you for watching. This video took a while to make, so liking the video would mean a lot. I'm definitely going to make more physics simulations or add to this one in the future, so stay tuned for some more videos. If you want to see me develop the framework that helped me make this simulation, click the video on screen. Anyway, peace.